Hi students, this is Mr. Yao. Today we're going to talk about 7.1b, where we will learn more specifically about tangent line, arc length, and sector area. So first, let's have a look at tangent line theorem. This is talking about a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. So there are some technical terms. First, we just got to know there is a tangent line right here, which is this one, line M. And this point, which is also the point of tangency, that is being referred as the endpoint right here. It's basically saying if we connect the point of tangency with the center of the circle, that is going to be a radius. And that radius is actually perpendicular to the tangent line. And something I want to emphasize on in this statement is it actually said, not only said that part, it actually said if and only if, which basically means we can actually go back and forth. So we can say, oh, this is a tangent line, then we actually connect this point of tangency with the center, that's going to form a 90 degree. We can also say if we actually have a line that is 90 degree with another, if I have a radius that is 90 degree with another line, then this line must be a tangent line. So that's tangent line theorem. Now let's have a look at how we can use it in an example. Example 1, PT is a radius and is asking if ST is tangent to circle. So basically we're trying to decide if it's a tangent or not. We're also deciding if it's 90 degree or not. And if we're actually dividing if it's 90 degree or not, we're deciding if it is a right triangle or not. And that means we're going to use Pythagorean theorem. We're trying to decide if this angle right here is a right angle or not. So 12 square, Pythagorean theorem, a squared plus b squared. We're trying to see if it actually is going to give us c squared. So 12 squared plus 35 squared. We're trying to decide if it is actually going to be 37 squared. And if you actually calculate it, that's going to be 144 plus 1225. We're trying to decide if it's the same as 37 squared, which actually is going to be 1369. The left side adds up to 1369. And that means it actually equals to 1369. So yes, it is. Example 2 is DE tangent to circle C. For this one, it wasn't labeled as clear. So if you think about it, if you consider 2 to just be to actually be this whole thing, that wouldn't make any sense because this is supposed to be the hypotenuse. Then of course it's no. So that's the one way. If you actually think CE, the whole thing is to no. The other thing is if you actually consider this little portion to be 2, this part would have to be the radius, which is 3. Then you're trying to decide if 3 squared plus 4 squared equals to the 3 plus 2 squared. Left side is 9 plus 16, which is 25, and the right side is actually 5 squared, which is 25. So if that's the case, then the answer is yes. That's example 2. Example 3. This time we're doing things slightly different. It's telling you already it is the point of tangency, which means this is going to be a 90 degree, and that is a right triangle. So we are actually going to solve that right triangle. Remember, is leg plus leg. So 80 squared plus r squared is not just like a smaller number, because the hypotenuse, this whole thing is actually 50 plus r then squared. We have 6400 plus r squared. The right side, remember if you actually want to deal with that kind of thing, you've got to write it twice. 50 plus r times 50 plus r. And that is going to give you 2500 plus 50r, another 50r, that's 100r, plus r squared. Then we can start solving, getting rid of the r squared, and this 2500 becomes 3900 on the left side equals to 100r. So r equals 39, don't forget the unit, feet. That is example 3. Next, example 4. Same idea, 24 squared, because if we want to say that's tangent, that this is going to be the right angle, which makes this longer, this is the longest side, the hypotenuse. So 24 squared plus r squared equals to 18 plus r squared, because this whole thing together is C. Pi is 76 plus r squared. That is going to be 324 plus 36r plus r squared. Same idea, we're going to get rid of the r squared and subtract 324 on both sides. That's going to be 252 equals 36r. R is going to be 7 after solving. And that is example 4. Next, we're going to talk about arc length. So arc length is a portion of the circumference, which tells you arc length won't be inside a circle. It's going to be around the circle somewhere. It's a portion of that circle. And unfortunately, we don't have a notation for that, so we're just going to call it arc length of AB. Something I want to emphasize on in this formula is right here. This measurement of AB is actually indicating central angle of arc AB. So whenever you see this little m, it actually is going to give you an angle, not a length. Now let's see how we can understand where did this formula come from. So arc length is right here. We're talking about this little arc AB. And 2 pi r, if you recall, that actually is the circumference. So the left side, we're basically connecting this little portion to the whole circle. And that is the same as this middle angle, the central angle right there, compared to the whole circle, which is 360 degrees. That's why on the right side, the ratio is the small central angle compared to 360 degree, which is corresponding with the circumference of the circle. Now let's see how we can actually use that. So example 1, find the length of AB. And AB is arc length, so we're going to set it up. Arc length AB. And we're comparing it to the circumference of the circle, which is 2 pi r. So 2 times pi times our r is 8. That is going to be the same as the central angle, which is 60 degrees, compared to the whole circle, which is 360 degrees. If you actually want to solve that, you can actually, that is actually going to be 16 pi, so we're going to multiply 16 pi on both sides. So arc length AB is actually going to be this 1/6 times the actual 16 pi. If you actually want you to keep a fraction, you can keep it as 8 over 3 pi, or it could actually be 8.38 centimeters. That's example 5. Example 6, find the length of GAH. Something to be careful with. This arc has 3 letters, which means it's actually talking about the major arc, which is right here, GAH, this portion. In order to know what is the central angle that we can use to form the ratio, you can see the smaller arc that is also using G and H as endpoints. That's only 120 degrees. So we're going to use around 60 minus 120, which is actually going to be 240 degrees. So now we can set up the ratio. Arc length GAH compared to the whole thing, which is 2 pi times r is 11. That is the same as the ratio, which is the ratio of the angle, 240 degrees, or 360 degrees. And same idea, we can actually multiply by that fraction, the bottom fraction on both sides, so times 2 pi times 11, times 2 pi times 11. And that is going to be GAH. That is going to be 46.08. Don't forget the unit, centimeter. So that is example 6. Next, example 7. This time you're given the arc length, is asking to find the circumference of the circle. So arc length is going to be, well, we can still set it up the same way. Arc length we're talking about is xy over circumference, which is C, and that is the same as this angle, 40 degrees over 360 degrees. And we already know this arc length is given, so that part is actually 4.19 inches. And in this case, we can actually do cross multiplication to solve it. Cross multiplication, so 40C equals 360 times 4.19 inches. We're trying to solve for C, so we're going to divide that over, and that is going to be 37.71 inches squared. That's example 7. Next, example 8. Find the measurement of RS. Again, when you see this little m, that means you're actually trying to find the angle, RS. And you can see this side is smaller. So we are going to set it up. Arc length, we're talking about RS, over. We can find the circumference, which is 2 times 15.28 times 5. And the right side is going to be the angle we're looking for. The angle is actually something we're looking for. So measurement of RS, the bottom is 360. And of course, this is going to be replaced by 44. So after putting in the calculator, that is going to give us the measurement of RS as 164.99 degrees. This is a measurement. That's example 8. Next, we're going to talk about sector. Sector is actually very, very similar as arc length. So instead of talking about length, which is just a string, how long it is, this time we're talking about the region. That's why it's going to be involving area. So when we actually want to calculate the area sector, you see we're going to use the 3 points. We're going to actually label the sectors this way. So this section, and if you recall what is pi r squared is actually the area of the full circle. So in this case, the right side is the same idea. This is the little angle we're dealing with, comparing to 360. Now let's have a look at some examples. Example 9. Find the area of the sectors formed by angle UTV. Something you gotta be careful with is this angle is not only forming one sector, it actually forms 2 sectors. First, sector, I'm gonna call that UTV over pi r squared, which is pi times 8 squared. That actually equals to the specific angle, which is 70 degrees, comparing to 60 degrees. So that is going to be 39.10. We don't have units. That's the first part. The second part, you have 2 different ways to do it. One is you can use the full circle, subtracting whatever we got from the first one. This one is a red. Now we're dealing with the blue. Sector UVST. So you can either use the whole circle, subtracting what we just calculated, or you can just set it up again. So sector UVST comparing to pi r squared, which is the whole thing. The right side actually is going to be, since that was 70 degrees, now it's going to be 290 degrees over 360 degrees. And for this one, the area is actually going to be 161.97. You should actually make up the whole circle. Next, example 10. Find the area of circle B. This time you're given an angle, you are also given the sector angle. So it's easier to set up. 35 over, I'm just going to call the area of V as V. That is the same as my angle is 40 degrees, and it's going to be comparing with so this time we do actually need to cross multiply because v is on the bottom of the fraction. After solving, v is going to be 315. That's example 10. Now we have two more. Example 11. Find the area of the circle. So for this kind of circle, for this kind of shape, which is actually a composite shape, so that means we're going to take them apart. And the simple thing to do is just use this line right there. And you can see the left side is actually going to be a semicircle. And the right side is just a typical triangle. So if we want to try to find the area, the triangle is 7 times 7 times 1/2. And the semicircle is going to be, from the figure you can kind of see the 7 right here, that is the diameter, but we only need half of it. So it's going to be pi times 7/2 squared. And that is not done because it's only a half, a semicircle, so we need to multiply by another 1/2. Now it's time to actually add them all up. So these two, 49/2, then plus 1/2 is right there, and then the other one we have 49/4. Now this question actually was decimal. I'm going to round it. That's going to be 43.74. Don't forget a unit, meter squared. If you forgot how to calculate the triangle, well, that's base times height times 1/2. That's what I did. Now let's have a look at example 12. It's asking us to find the area of the shaded area. That means since we don't exactly just know the shaded area, we kind of need to find the angles. We see on the left side and the right side, the angles are given. We have the 109 on the left side and the right side. So we're going to get rid of it first. 360 degrees minus 109, that's the left one, minus 109, that's the right one. That's going to give us 144 degrees. And that actually is the shaded area altogether. If we actually separate them, we can know that's 72 degrees, and that is also 72 degrees. But we don't have to separate them because we're calculating the shaded area altogether, and that is inside a circle. So we can say shaded area comparing to the whole circle, which is pi, my r is 5.2, so times 5.2 squared. That is the same as the angle of the shaded area is 144 degrees. The whole circle is 360 degrees. So if I actually calculate it by multiplying both sides with this pi times 5.2 squared, I'm going to do that on both sides, times pi times 5.2 squared. At least the left side, they're going to be gone. So I just need to calculate my right side, which is going to give me 33.98. We have a unit feet, so it's going to be feet squared. That is everything for 7.1b. Thank you.